Welcome to this video on IPv6 network and broadcast IDs. In this series on networking fundamentals, we will explore how network identification works in IPv6 and why the concept of broadcasts has been retired. To understand IPv6, we must first review IPv4. An IPv4 subnet, like 192.168.1.0/24, is divided into a network ID to identify the subnet, a usable host space for individual devices, and a broadcast address used to communicate with every device on that segment simultaneously. Broadcasting in IPv4 comes with significant drawbacks. Every node must process broadcast frames at the CPU level, which can create broadcast storms, waste bandwidth, and negatively impact device performance, especially as networks scale. IPv6 addresses this by eliminating broadcast addressing entirely. This architecture reduces background traffic, prevents legacy loop issues, and allows subnets to scale much larger without performance degradation. In IPv6, we use a network prefix to identify the subnet. Just like the IPv4 network ID, the prefix, such as 2001, DB8, ACAD1, skeptical smiley face 64, acts as the architectural boundary that tells routers where the subnet begins and ends within the global routing table. IPv6 addresses follow a standard 50-50 split. The first 64 bits represent the network prefix, used for routing, while the last 64 bits form the interface ID, identifying the unique host. Using a /64 boundary is the fundamental requirement for most networks. Since broadcasts are gone, IPv6 uses highly targeted multicast. Traffic is sent only to specific groups. Only devices that have opted in will process the traffic, saving bandwidth and preventing unnecessary CPU wake-ups on uninterested devices. There are two critical multicast groups to remember. FF021 is the all nodes address, acting as the closest equivalent to a broadcast, while FF022 is the all routers address, essential for neighbor discovery and routing lookups. IPv6 also introduces Anycast. This allows multiple devices to share the same address, with routers delivering traffic to the physically closest instance. It is commonly used for DNS root servers and high-availability load balancing. To contrast the two, IPv4 relies on network IDs, broadcasts, and ARP, often facing address limitations. IPv6 shifts to network prefixes and native multicast, providing a massive, virtually infinite address space. For your exams, remember these 3 points. IPv6 has no broadcast addresses. It uses targeted multicast instead, and the network prefix defines the routing domain. In summary, IPv6 improves efficiency by replacing broadcasts with multicast and uses clear prefix and interface ID separations. Mastering these concepts is essential for modern networking certifications.